The following grouped frequency distribution summarizes the number of minutes to the nearest minute that a random sample of 200 motorists were delayed by road work on a stretch of motorway. So this is the delay time and this is the number of motorists. In other words, this is the class and this is the frequency. We have to draw a histogram. To draw a histogram, we need to have the class boundaries in the x-axis and the frequency density in the y-axis. Let's find the frequency density first. Question number A. Frequency density equals to, you have to notice that there is a gap here. 6, then we have a gap 7, 8, then we have a gap 9, 10, then we have a gap 11. So since there is a gap here, but the data is supposed to be continuous data, so we have to do some continuity correction to fill up the gap. This is done by just putting a 0.5 to fill up the gap. In order to find the frequency density, the formula is frequency divided by class width. Class width is going to be upper boundary, class boundary, which is 6.5, minus the lower boundary, which is 3.5. So instead of doing 6.5 minus 3.5, 8.5 minus 6.5, we can do one thing. We can use a trick. 6 minus 4 plus 1. So this would be 6 minus 4 is 2 plus 1, 3. So frequency density is going to be 15 divided by 3. The next one is going to be 28 divided by upper boundary is going to be 8.5, lower boundary because of the gap. So it's going to be 6.5. So instead we can do 8 minus 7 is 1, 1 plus 1, 2. So this would be 2. Then the next one is 49 divided by 9 is going to be, upper boundary is 9.5, lower boundary is 8.5. It is going to be 9.5 minus 8.5, 1, or you can do 9 is the upper boundary and the lower boundary is also 9. So 9 minus 9 is 0 plus 1. So this is going to be 1. When you have a single term, it is just 1. Then 53 is divided by, class width is going to be 10 minus 10 is 0 plus 1 is 1. Then we have 30 divided by 12 minus 11 is 1 plus 1, 2. Then we have 15. 15 minus 13 is 2 plus 1, 3. And then we have 10. 20 minus 16 is 4 plus 1, 5. So this is going to be 15 by 3 is 5. 28 by 2 is 14. 41 by 1 is 49. 51 by 3 is 53. 51 by 1 is 53. This is 15. This is going to be 15 5s are 15, 3 5s are 15. And this is going to be 2. This is the class boundaries. This is the height of the histogram. The frequency density is the height of the histogram. So the class boundaries, now we have to put it here on the x-axis. Let's directly draw the histogram now. So let's draw the x-axis here. Okay, so this is the x-axis and the y-axis is going to be here. I hope this is straight. Okay. Okay. So this is the y-axis. We have to label the histogram since the data here is delay time. So we have to write here delay. Let me use something darker. Delay. So delay time in minute. This is the x-axis. The x-axis will also be the data. So the data is delay time, and the y-axis is always frequency density, FD. This is the y-axis. This is the origin. Let's label it. So it starts from 3.5 because we have to do the continuity correction because of the gap here, and ends at 20.5. So if you take 5 like this, so 5, 10, we can take actually more. We can take this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We can take this as 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is good enough. So the first thing, the height we need up to 50 something, so we can take it as 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So that's it. Let's label this 3.5. So if this is 2 and this is 4, then 3.5 is somewhere around here. This is 3.5. Then we need 6.5. So 4. Then we have 6, 6.5. This is somewhere around here. 6.5. And the height of this building is going to be 5. So it is going to be like this. This is 5, so it will be this. So this is 5. The next one is 7 to 8. That means 6.5 to 8.5. So 6.5. This is 8. 8.5 is somewhere around here. So this is 8.5. And the height of the building is 14. So 5, 10, 15. So 14 is here. So this is 14. This is an approximate sketch because here the boxes are very small, so it will give you an idea how the sketch is done. The next one is 9. 9 means 8.5 to 9.5. 0.5 minus 0.5 plus. So 8.5 to 9.5 is going to be, if this is 8.5, 9.5 is going to be around here. And the height of this building is going to be 49. So 20, 25, 30, 35, 40, 45, 50. So 49 is going to be here. So the height is going to be here. Okay, it will give you a rough idea. So this is going to be 49. The next one is 9.5 to 10.5. So 9.5, this is 10, 10.5 would be here. So the height would be up to 53 this time. So 53 is going to be 50, 51, 52, 53. This is going to be the building. The next one is 10.5 to 12.5. So this is 10.5. Now this is 12. 12.5 is going to be this. And the height is going to be 15. So this will be the height. This is the height for that building. Now this is 12.5 to 15.5. So if this is 12.5, this is 14. This is 16. So 15.5, somewhere around here. 15.5, and the height of this building is going to be 5. So this is going to be 5. Okay, the next one is going to be 15.5 to 20.5. So this is going to be 16, 18, 20. 20.5 is going to be here, and the height of this building is 2, so it would be here. So this is 20, this is 18. So this is going to be the histogram. Since we have a gap here, for that reason we have to take the continuity correction of 0.5 and 0.5. The next question is, give reason to justify the use of histogram. The reason is always if the data is continuous. If the data is continuous, we have to use a histogram. So B is going to be, since time is continuous, we need to use a histogram.